Similarly, we can prove the third one, d by dx of tan inverse x is equal to 1 by 1 plus x squared. Number 4, d by dx of cot inverse x is equal to minus 1 by 1 plus x squared. Next, d by dx of secant inverse x is equal to 1 by x into root of x squared minus 1. Number 6, d by dx of cosecant inverse x with a minus sign, minus 1 by x into root of x squared minus 1. So these formulae can easily be remembered. If you know secant inverse x, cosecant inverse x is what? With a minus sign. If you know tan inverse x, cot inverse x is what? With minus. And if you know sin inverse x, a differentiation of cos inverse x is what? With a minus sign. Now we can also, from first principles, we can prove any problem in inverse functions. As a sample, we can take up this particular thing. Differentiate tan inverse 2x with respect to x from first principles. Let y is equal to tan inverse 2x, then 2x is equal to tan inverse y. Same method, let delta x be a small change in x and delta y be the corresponding change in y. Then wherever x is there, x plus delta x. 2 into x plus delta x is equal to tan inverse y plus delta y. Not tan inverse, tan only. Tan y plus delta y. Here also inverse is not there. So then what do you get here? Let me now divide both sides. Now below that you write 2x is equal to tan y. Then we subtract, you get 2x and 2x cancel, 2 delta x is equal to tan inverse a tan of y plus delta y minus tan y. Divide both sides by delta y and take limits as delta y tending to 0. So 2 into delta x by delta y, limit delta y tending to 0 is equal to limit delta y tending to 0 tan of y plus delta y minus tan y by delta y. Left hand side becomes 2 into dx by dy. Right hand side limit delta y tending to 0 tan y plus delta y. You write as sin y plus delta y by cos y plus delta y minus tan y is written as sin y by cos y by delta y. Now take LCM. limit delta y tending to 0 sine y plus delta y into cos y minus cos y plus delta y into sin y whole divided by LCM and together with delta y. Delta y into cos of x plus delta x, cos of y plus delta y into cos y. Now numerator limit delta y tending to 0 sin a cos b minus cos a sin b sin a minus b sin y plus delta y minus y and y cancel, denominator remains same. Say that is what delta y into cos of y plus delta y into cos y. Now write in the standard form where you can evaluate the limit delta y tending to 0, numerator sin delta y, denominator is what delta y. Combine together, put it in a bracket and the rest of them as cos y plus delta y into cos y. Now this one sin delta y by delta y, it becomes automatically 1 and the rest of it is what 1 by cos y plus 0 into cos y, or this is what 1 by cos squared y, and that is nothing but secant squared y. Secant squared y is what 1 plus tan squared y is what 1 plus tan squared y is what 2x whole squared, 2x whole squared. So therefore dx by dy is equal to 1 plus 4x squared by 2, or therefore dy by dx is equal to 1 by dx by dy, and that is what 2 divided by 1 plus 4x squared. Later on you will see in composite functions, if you differentiate tan inverse 2x and 1 by 1 plus 2x whole squared multiplied by differentiation of 2x as 2, you get it. Now we take some simple problems. Differentiate the following. With respect to x. Say y is equal to sin inverse x minus or plus 2 cot inverse x plus 3 secant inverse x. We are covering the formulae, whether say to revise the things like this. Sin inverse x is what 1 by root of 1 by minus x squared. Cot inverse x is minus, so plus 2 into minus 1 by 1 plus x squared plus 3 into secant inverse x is what 1 by x into root of x squared minus 1. So there is nothing here, we can directly write root of 1 minus x squared minus 2 by 1 plus x squared plus 3 by x into root of x squared minus 1. We are directly covering the formulae or work out the problems while working out the problems. Next, y is equal to 2 tan inverse x plus 3 cos inverse x minus 5 cosecant inverse x. That means all the formulae we are covering. Dy by dx is equal to 2 into tan inverse x differentiation is what 1 by 1 plus x squared, and plus or directly I write 3 cos inverse x is what minus 1 by minus here 1 by root of 1 by minus x squared minus 5 into cosecant inverse x is what minus 1 by x into root of x squared minus 1, and that particular thing can be rewritten just like this only, 2 by 1 plus x squared minus 3 by root of 1 minus x squared minus 5 into minus is what plus 5 by x into root of x squared minus 1.